Running traditional tools manually can take weeks or months of time. Our NEEMAT, National Energy and Emission Modeling and Analysis tool, it's an interactive web application, replaces with an AI-based machine learning pipeline that gives us similar results in the seconds. On the text side, the front end is React, Vue, Tailwind CSS, and the Material UI, having the interactive charts. And the back end is a Flask API, SQLite, and PyTorch models that acts as lightweight surrogates for the mouse and Cambium. So we have the input data analysis and the results. Input data has the four input pages. So and the city we have the Atlanta, Los Angeles, Seattle, and the New York. So when we click the Atlanta city, a track map appears on the right side, and on the left side you can able to pick the 2024 base year where our calibration data begins, and you can able to see the 13 vehicle classes. You can able to filter the data and you can able to edit the data. So coming to the next page, which is the projection penetration rate data, base year and the city is fixed, and you can able to select the projection year, and you can able to filter the data, and you can able to upload the projection years data. If you go to the next page, which is the traffic volume and speed, user will upload the traffic volume and the traffic parameters, which is the MFT parameters. And if we click the estimate speed, you can able to like the backend runs the track level machine learning model, converts the traffic volume to speed over 24 hours and plots the typical daily patterns. You can able to see the increase in the traffic volume and the decrease in the traffic speed during the office hours, like the 7 a.m. to the 7 p.m. And these are the MFT parameters that we are run to calculate the speed. Coming to the projection demand, we upload the projection demand, and if we can select the projection year, user can able to rerun the machine learning model, and we can able to predict the next 5 years. These are the projection increase in the traffic volume for the next 5 years. And we are going to the analysis page now. User can able to pick the fuel type, emission type, and vehicle age. And if you click the predict and plot, user can able to get like the backend takes the data and sends it to the neural network model trained on the large batches of the moves 4.0, and the plot shows the fuel type versus speed, and the CO2 like the emission versus speed. So if you place the hover there, you can able to see the x-axis values and the y-axis values as well. So it has the r square above 0.99. It's almost accurate, but essentially the real time. Coming to the next machine learning model, which is the grid emission rates, was trained on the Cambium and REL scenarios. So when we pick any of the emission like CO2 or methane or nitrous oxide, you can instantly see the grid emissions for all eight scenarios. So across all eight scenarios, there is a growth of 2030. So CO2 rises for 70%, CH4 for 80%, and N2O for 60%. So extreme scenarios pushing the N2O even more higher. Coming to the next results page, user can able to switch between the vehicle or grid or daily or annual. And if you click the fuel type and the emission type, you can able to see the 24 hours profile with the 15 minutes resolution. And the coming to the annual, you can able to see the multi-year trends. All these are the downloadable, and then the annual, you can able to see the downloadable. Putting everything together, NEEMAT lets planners to explore how the traffic growth and the EV adoption and the grid decarbonization interacts. Even with the strong EV uptake, EMAT emissions can still rise if the traffic keeps increasing and the grid stays carbon intensive.